second number one. The second number one, which is your real number 2, this is a function because when the radical is there, it's whatever sign is in front of it. So it only has one arm to this guy. Only the one arm is this. It's different from this one because if you take a look at it, this is y squared. When you take the square root, you get a plus or minus.
Wait, isn't x squared minus 1 a perfect square?
X squared minus 1 is your parabola, is your parabola underneath your radical, yes. But what you care about is this a function. If you graph this thing, you graph this in your y equals, just like this.
But I mean for number 2, like when you square both sides, is it...
Oh no, don't square both sides. You want to solve for what? If you square both sides, then you have y squared. You want to solve, remember, solve for y.
It's hard to take the square.
Yeah, you can't take the square root of this because you're talking about number 4. You can't take the square root of this because these factors are perfect squares. They're not x plus 1, x plus 1. You could take the square root of that, but the problem is not this part. The problem is this part, the y squared. If you want to solve, every x can only have one y. So what happens here is pick an x. Give me an x value. Okay. Let me get rid of all this junk. Okay, so 2. All right. When x is 2, watch. 2 squared is 4. 4 minus 1 is 3. So when x is 2, y is radical 3. Good? Now, in this one here, here's a problem. You're going to take the square root of this.
Oh wait, don't you not want square roots? So wouldn't you square that and then
No. You can have whatever you need in that equation. All we're checking for is does every x have one and only one y? All we're checking for is it a function. So you have to solve, remember yesterday's directions, you have to solve for y equals. So now, watch. If I put x is 2 in here, when x is 2, y can be radical 3, or y can be negative radical 3. See it? So if I'm looking at a graph, here's 2, radical 3, here's 2, negative radical 3. It doesn't pass the vertical line test. The problem is not this part of it. The problem is this part of it right here, the y squared. You have to solve for y. You can't put any equation in unless it's y equals. So what happens is a function, the definition of function says every x gets one and only one y. If I put an x value in here, this is going to get 2 of them. If I didn't square this, watch. If I left it like this, and I put your x is 2 in here. So this will give me 4 minus 3. This 4 minus 1 is 3. How do you solve for y? Square root. When you take the square root, there's your plus and minus. So this 1x has 2 y's that belong to it. If it has 2 y's that belong to it, it is not a function. You only have one y, one and only one y. So your goal is to get y by itself. Now the difference between this one and this one, the square root is already here. When the square root is already there, you take whatever sign is in front of it. In this case, positive. So I only get one y that's going to get assigned to it as opposed to this one. See the difference? You're just finding out is this a function. You're not solving anything. Don't overthink it. As basic as put it in your y equals. And I would have a hard time putting this in my y equals unless I took the square root. And when you take the square root, you have to put 2 caps in. Okay, this was nice. This is just a line. And this will tell you right here. Your exponents are both 1. Every x is going to get 1 y. It's when your exponent has 2 or more, or if your y isn't an absolute value, you're in trouble. This guy here, this is a line. X equals negative 7 is a vertical line. It doesn't pass the vertical line test. That x has every y that belongs to it. Okay. See the difference? Okay, these guys, was everybody okay with this? You had to plug in first a 4, a negative 4, wherever you saw t, So you plugged in your -4 right here, and you're working this part. So when the function f has a value of t at -4, same as your x, the value of your function is -11. That's your y value that's coming out. In this one, they wanted you to put t plus 2 in here. Same process as this. Go to this guy and just put in t plus 2. That's going to get you ready for today.
So number 9, why is B like for Q? Why is that 2?
Could we,
No, on the sheet it's 0.
oh, it is?
Yeah.
Okay. My mistake. I probably put the wrong one in here when I was working the problem out. That's my mistake. As soon as we get to that, I'll do it with a 0 on it. I probably just wrote down the wrong number when I was writing my own sheet out. But that's odd because this is from my worksheet. Maybe I scrolled over something and changed it by accident. Okay, so is everybody okay with this one? This is a really important one. Can everybody see that one? We substituted t in for -4 in for t. Then we substituted in for t plus 2. Everybody good with that? That's going to lead us into today. So same thing here. Now the only problem with the second one is you have 2 t's. So 1.5 has to go into both of them. Then x plus 2 goes into both of them. And be careful of this guy. This is x plus 2, God bless you, times x plus 2. Even on your test, I had a lot of you guys, I say over and over again, you have to FOIL that out. And some of you didn't. Number 9, I'm just taking this x and first plugging in a 2. Then I'm taking this and plugging in a y plus 3. So this is the one where there was a 0. Okay, so let's do q of 0. So let's plug in 1 over 0 squared minus 9. Is that what you got? Okay. I don't know how I changed it. Alright, now this one, after you FOIL this, collect your like terms. These are going to cancel out. Don't leave it where the terms are not collected. Good? And these guys were your compositions. How'd the compositions go? It's important that you can do these as well. There are 2 functions, an f function, which is a line, and a g function, which is a quadratic, your parabola. That's your squaring function. In the first one, you just had to plug the numbers in. The second one, the equations in. If we take this and we plug that into this equation, we should get the same answer as this. So 6 times 4 squared minus 3. This should give me 16 times 6 is 96. Minus 3 is 93. That has to work. Once you find the equation, that has to work. And what you normally is if you have a bunch of these, you want to find the equation first. It makes your life easier. You can also take this equation and put this in your y equals and go right to your table and pull out when x is 4. Oh, my y is 93. This one, they plugged in a 2. So if we plug a 2 into this guy, if you put this in your calculator, this should equal 3. 4, this will be 48 minus 72 plus 27. And this will be 75. There's your 3. Okay, once you find the equation, go back and check it. That's your check to see if it works. You did with your numbers. Okay. This is a little bit of review, a little bit of substitution, because today we're going to do something that involves a lot of substitution. So this is kind of like getting you back on that track. Yep. the last part I gave you again, domain restrictions. We work with domains the whole time in this course. We do a lot with domains in here. So it's important that you catch it. A lot of you, I noticed on the test, had trouble whenever you had a denominator. You only have 3 restrictions. Remember your 3 domain restrictions. 1, the denominator in a fraction. Set it equal to 0. Those are the ones you cannot use. Then take them out of your domain. That leaves you your restricted domain. 2, under a radical. Actually, it's under a radical that has an even index. Set it greater than or equal to 0 and solve it. That's your domain. The third one is a radical under a denominator. Set it greater than 0. It can't be equal to 0. Excuse me. The first one has none of those 3. Means any x I want, I can plug in there. Any x. There's no restriction on what x I can use. All real numbers. The second one, I have a denominator. Set it equal to 0. The only thing I can't use is this guy. So take it out of your real numbers. Otherwise, I'd be able to use every number that I wanted to. But I can't use 0. So take it out of your domain. This side is tricky. This index is 3. If it was a square root, I would have to say, whoops, set this greater than or equal to 0, and x has to be greater than or equal to 4. But in an odd index, there's no restriction because you can have a negative underneath under the radical. Cube root of -8 is -2. -2 times -2 times -2. You can have a negative underneath your radical if your index is as odd. Not if it's even. So this one has no restrictions. Number 14, you have 2 denominators. 2 places that you are going to have a problem with a 0. Go like this. Just put a 0 here. You can't make that be 0. Set them equal to 0. You can't use a 0 or a -2. Take that out of your domain. This is the domain that you're allowed to use. This is called your restricted domain. You took out your restrictions and you're left with the rest of your domain. The last one, 15, it's the third one. You have a radical under a fraction in the denominator. Take this piece and set it greater than 0. You can't have a negative, and because it's in a fraction, you can't have a 0. So set it greater than 0. So from 10 to infinity, you can use, and test your domain. Test it. See if 11 works. 11 works. See if 9 works. Whoops, 9 doesn't work. You didn't want it to work. 10 doesn't work. These are your 3 domain restrictions. Good? Okay. I haven't taught Algebra 2 in 2 years, so I forget if I taught it or not. Yes. You don't have it. Yes, you do. I handed it out. Just this morning. I just gave it to you guys. While they were doing the messages, I said, let me hand this out. Anybody else doesn't have it? Your whole row? Yeah. Because you guys are late. Okay, if we can switch this one back to the out. That has to go back to the out. Oh, you too? Wait.
She didn't have any.
You didn't? Yeah. I just handed this out. During announcements. Okay. Difference quotients. Boys in the back. actually is a calculus procedure here. And we use this to find the average rate of change. The hard part about this is we're going to be doing this, and you're not really going to see a need why we're doing this until the end of the course when we throw limits at you. We do a small calculus unit called limits. You do a lot of calculus in here, but we rename them towards the end and we call them a limit as something approaches something. We look at, in this case, we always, you know when they do this, which cannot be zero, they take your denominator and they say it cannot be zero. Your denominator can never be zero. So what happens is, your graph, somehow as it approaches when x is zero or when h is zero, it causes the graph to go either over it, around it, split. We have to figure out, does it have a limit? Does it reach a certain value? So at the end of the year, at the end of this year, we'll kind of do this again and we'll hit this with a limit. But for now, this is how you approach your difference quotient. Every college algebra course does a difference quotient. Our goal is to eliminate this h from the denominator, because we don't want to have a situation where we approach a zero and can't use this. Our goal is to eliminate that. Now, what we're going to do is, they give us, it's just a series of substitutions. And this is what I want you to do. This is the easiest way to do this. You see this f of x, right? This is our function notation. This function f is what is this going to give us? X squared. This is our function x. Now, x squared, which is your square root. This right here should read f of x, right? Because I want it to look like this, f of x. So I want you to take this x plus h and put a squiggle, put x over it. That's your f of x, your f at x. Your function when that value of x is x plus h. You just did this for me. You did f at 2. Then you did f at t plus 2. Remember when you did the t plus 2? And you done the homework and you substituted it in? So all we're doing is, instead of saying f at 2, I'm saying f at x plus h. And f of x at x is in fact this whole thing right there. So all we're doing is substituting this in. So watch first and then I'll do it again. We're going to take this x plus h, and wherever you see x, just like you did for your homework, God bless you, you're going to substitute it in. So this says x plus h squared. It's exactly what you did for your homework. And then you squared it and figured it out. Well, this has a little bit more to it. So then we're going to put the minus, and then it says, oh, take your function, f. My function f is x squared. And I'm going to place it over h. The same as this. All we did was substitute this in. I'll do it again. Just I want you to watch first. Then we take this, we square it. This gives me x squared plus 2xh. That's h squared. That's this. And we also have your minus x squared. Now, at this point, after you've collected your like terms, you're going to eliminate, you're going to condense the numerator. You're going to eliminate things that don't have the h in there. It's going to automatically eliminate x squared, negative x squared. All that's left is my 2xh plus h squared. I'm going to factor out the h. And now I'm going to reduce my fraction by a factor of h. And my denominator is gone. There's nothing to solve. It's going to come as an expression. But my goal was to eliminate the h. I'm going to do the whole thing again. I just wanted you to watch first. Okay? So let's walk this through again. This is the same thing that you did for homework last night. This was your function. You substituted into the x, right? I want you to take this. This should say f of x. So that's where my x goes now. We did this with the t plus 2 in the first one. You're going to take this piece right here and substitute it into x squared. So x plus h, and we still have to square it. That's my whole function, x squared. I'm replacing x with x plus h. Then I have a minus sign. It says subtract your function f. What is my function f? X squared over h. Now all I have to do is resolve this. We did the x plus h. We got x squared plus 2xh plus h squared. That was this piece. Minus x squared. Now, when you condense your numerator, you should only end up with h terms. X squared and negative xh, x squared and negative x squared, gone. I'm left with 2xh plus h. Now, back h squared. Thank you. Now, factor out, these guys have to have an h in them. If something is left there without an h, that means you probably didn't distribute a negative sign, maybe you didn't square it correctly. Everything that's left has to contain an h, because you're going to factor it out. And then it's going to factor out.
What happens to the square?
I factored out an h.
So that GCF, where it's time factor, is h. So if I take the h out of here, gone. If I take the h out of here, one's left. That's why your terms that are left have to contain an h. All we're doing is making a substitution. Same thing you did on your homework last night for your function notation. We're just plopping it into this difference quotient. Okay, let's try another one. The same exact equation, but look at the difference. Instead of x plus h, I'm going to use 2 plus h. Instead of this x, I'm going to plug in a 2. So watch what happens. Start like this. This is your x. This is your x. Just do that first. And it makes such a big difference if you do that. Put parentheses in your original function wherever you have an x. Wherever x is, it has to be replaced. So first time through, we're replacing x with 2 plus h. So I plug in my 2 plus h, I still have to square it. So all I have is one little x squared in my function. Minus, I'm replacing x with what? 2. So I'm taking this, 2 squared. I still have the h. This guy has to get FOILed. So I get 4 plus 2h plus 2h minus 2 squared is 4. Now remember, when I condense the numerator, I have to get rid of every term that doesn't have an h in it. So it works out perfect. 4 and negative 4. Gone. So I factor out, I'll remove this now. They both contain an h, so factor out the h. And now you can take out the common factor. And you're left with 4 plus h. It's the same as you did last night. Same substitutions. But we're just holding it in this little quotient here. Questions so far? Okay, let's try one more. Okay, a little bit messier. Let's take this. This is my x. This is my x. Put parentheses wherever you find x. My function f has 3 terms in it. 2 of them contain an x. So when I substitute in, I have to substitute into both x's. So the first time, what am I substituting in? 2 plus h. So I've got 3, 2 plus h, minus, parentheses, 2 plus h squared,
And then the rest of my function plus 5. Minus, now, this is the tricky part. Put parentheses around this guy because you have more than one term. 3 times 2 minus 2 squared plus 5. Everybody get that? This was your x. This was your x. This was your x. Your x. See it? You looked at it again? There's your 3x minus x squared plus 5. There's your 3x minus x squared plus 5. Now we have to resolve your numerator. Distribute this one. Watch this minus sign. You have to FOIL this guy. And you have to subtract the entire trinomial, not just the first term. So 4 plus 2h plus 2h is 4h plus h squared. Put this inside that parentheses. This is one of the most common mistakes right here. Plus 5. Now, this is nice because we can work this out. 2 squared is 4. 3 times 2 is 6. 6 minus 4 is 1. Plus 5, 6. What?
7.
7.
6 minus 4 is 2.
6 minus 4 is 2. Plus 5, 7. Okay. Now, if that wasn't right, I'm going to see that at the end. It won't cancel out. So thank God I had 12 here. Now, the next thing we have to do is distribute the negative sign. 6 plus 3h minus 4 minus 4h minus h squared plus 5 plus 7 over h.
You can combine 5 and 7.
Yes, you can. Yes, you can. I just left them all there. So now,
Yeah, never mind.
Wait, you said 6 minus 4 plus 5? So 6 minus 4 is 2, and then you add 5 is not 7. So where the other 5 comes from?
The first
From
problem.
the first one.
that's the first problem. All this piece resolved into this. But however, I forgot this guy. Sorry about that. Is a negative sign. See it? Sorry about that. Because it wasn't going to cancel out. And the negative signs catch you every time. We just had to put the minus sign here. Okay, so let's resolve this. 6 minus 4.
I have a question.
Okay, wait. 6 minus 4 is what? I just want to go through this and then I'll answer your question. 2. 2 plus 5 is what? 7. 7 minus 7 is 0. That's not. If it wasn't, we got to go back. So if it wasn't, and I left this as a 6, I'm going to go back and find, oh, I made a mistake right here. If it still didn't cancel out, I look at my negatives because it's usually the negative that you didn't catch. The negatives to positives, you always got to make sure that the negatives are there. This is another spot right here with this negative. Luckily, the 4 was in the beginning, because even if you forgot your parentheses, you'd end up with a negative 4. Question?
So did you distribute the negative to that?
Yes, into this thing. Because look, you're subtracting this whole product, not just the first term. Okay, so now let's,
I was just
Work.
confused where all the negatives came from.
right, from that. If it was one term, not a problem. But if it's any more than one, parentheses. Now collect your terms. You have 3h minus 4h is what? Negative h. Minus h squared. Is there anything else that has an h here? Nope. Take out an h in the top. You could take out a negative or just take out an h. Negative 1 minus h over h. And the h's come out. And you are left with negative 1 minus h. I can't move my screen or I'll lose all that information, so I'm sorry it's kind of messed up at the bottom there. Your goal when you condense this is to get rid of anything that doesn't have an h. If it didn't, then something went wrong.